Hi, welcome to today's lecture. This is Narsimlu Madhuri. In this lecture, I am going to discuss how to implement IEEE paper. The IEEE paper is a prediction of Parkinson's disease and severity of the disease using machine learning and deep learning algorithm. The objective of this lecture is what is an existing system, the approach and proposed solution and process flow diagrams, technical aspects, few code snippets, sample screens and conclusion. So here let me see one by one what is existing system. In this, the author implemented the paper, that is detection of Parkinson disease using machine learning algorithm. Here, a prediction of Parkinson's disease severity using deep learning algorithm. This was implemented by the author. In the proposed system, what I am doing here, detection of Parkinson's disease using machine learning algorithm. I am deploying that machine learning algorithm using Flask. The another proposed model is your deep learning algorithm. That deep learning algorithm is predicting the Parkinson's disease severity and deploying that model using Flask. First of all, we should know about Parkinson disease. What is Parkinson disease? Parkinson's disease is a progressive disorder of the central nerve system affecting movements and inducing tremors and stiffness. Here, Parkinson disease is chronic and has no cure yet. What is the major factors in Parkinson's disease here? Tremors. What do you mean by tremor? The tremor is a rhythmic shaking movement in one or more parts of human body. It is most often in hand, arms, head, vocal cords, trunk and legs. The another factor here, levodopa. The levodopa is treatment for Parkinson's disease. This is basically nerve cells use levodopa to make dopamine to replenish the brain's dwindling supply. A dopamine is a neurotransmitter. It plays a role in sending messages to the parts of the brain that controls movement and coordination. The another factor here, motor UPDRS. In this, what is motor? A motor is sign of Parkinson's disease and that affect the body's movement, and it assesses the patient's motor capacity in the scale of 0 to 108. The total UPDRS. This total UPDRS assesses the patient's overall ability and its score ranges from 0 to 176. Here UPDRS means Unified Parkinson Disease Rating Scale. This is numerical value. Let me talk about the data set of this Parkinson's disease. Here The data set is TUPI keystroke data with Parkinson's patient. These data which has two categories. One is typing data of the archived users. This typing data of the archived users contains the information about participants. These participants from the various countries such as United States, UK, Canada and Australia. This participant information contains the birth year, gender, Parkinson's, year of diagnosis, levodopa. So these attributes are there in this data set. This entire data set is in the form of text form. Each user is having own text file. Now another data is your TUPI data. Here in TUPI means it is a software. The keystroke acquisition software. This software generates the timing accuracy of the key presses like hold time, latency time, flight time. So these parameters attributes are there in the TUPI data. This is all about Parkinson's disease data. Here this is the data, but these data I converted into my required form which is needed for the algorithm here. This is the first archived users data, that is a birth year, gender, Parkinson's, tremors, diagnosis year, sided, whether it is affecting left side or right side or nowhere in the human body. Then UPDRS, that is Unified Parkinson's Disorder Rating Scale, impact, whether it is impacting medium, mild or severe. Levodopa, whether treatment is medication has been applied to that disease or not, that is Boolean values only here. The another data here, TUPI data, that is recorded in the TUPI software. So that is on which date and timestamp, whether hold date keys here. Here we have 9 keys, that is left space, left right left, like that we have it here. Then hold time, direction, latency time, flight time. This is a data. Another data here, Parkinson's telemonitoring data. With these data we are predicting the severity of the Parkinson's disease using deep learning regression algorithm. These data which consist of several attributes here, that is subject, that is uniquely identifies each subject and the age of the subject, then gender, 0 for male, 1 for female, and test time, when the test was taken by the particular patient here, that is the time since recruitment into the trial. The motor UPDRS, this is clinician's motor UPDRS score. Total UPDRS, this is clinician's total UPDRS score. Jitter, this is several measures of variation in fundamental frequency. Shipmer, several measures of variation in amplitude. Next parameter, next attribute here, NHR, to measure the ratio of noise to tonal components in the voice. RPDE, this RPDE, recurrence period density entropy, that is nonlinear dynamical complexity measure. The another one is DFA, this is detrended fluctuation analysis, that is signal fractal scaling exponent. These all attributes in the numerical form only. The last attribute in this telemonitoring data here, PPE, non-linear measure of fundamental frequency variation. This is all about telemonitoring data for predicting severity of Parkinson's disease using neural network regression algorithm. The approach which I used here, identification of data, meaning here where I get the data, so that is data source. Here the author did research on Parkinson's disease data for predicting the severity and detection of Parkinson's disease on these countries, that is US, UK, Canada and Australia. That is research was done by the author in this. Now here the author used the approach is detection of Parkinson's disease using machine learning XGBoost classification algorithm, predicting Parkinson's disease severity using deep learning neural network regression algorithm. What I added in this here, I deployed this model on Flask framework for seeing the better results in the front end. Let me see one by one. Identification of data. The data is available in this source for detection of Parkinson's disease, and this source the data is available, that is TUPE keystroke data with Parkinson's patients. Now the data is available here. You can see the data here. Here the data is there. You can just bear with me. Here this is for detection of Parkinson's disease using XGBoost algorithm. In this, once we downloaded this data, the data which contain two folders, that is archived users and TUPE data, which I explained earlier, predicting the severity of the disease. So for that the data source is this, that is Parkinson's telemonitoring data, which is available in UCI. So we can also download it from here. So I downloaded it here. So this is all about data which I identified based on the paper. Now let me talk about the algorithm, so which I am going to apply for implementing this paper. First of all, we should know about the algorithm, and then we are going to implement this paper using that algorithm. In this, so we used supervised algorithm. Supervised algorithm meaning here target label, when we know the target label, so target label and the feature label both are identified, which is comes under supervised, that is a supervision is there for predicting the target label. Here that is supervised algorithm is broadly categorized into classification model and regression model. In the classification model we have binary classification, multi-class classification. What do you mean by binary classification? The dependent variable, that is dependent variable value is discrete, is binary categorical, either true or false or 0 or 1. Only two labels are there, which is comes under binary classification. In this project Parkinson's disease is dependent variable which has two categories such as true or false. Now, regression model. Regression model is applied when the target variable value is in continuous form. We will apply regression algorithms. In this project, Parkinson's severity is dependent variable. So here this Parkinson's severity we are predicting using neural network algorithm. Let me see, the algorithm is your XGBoost. What is XGBoost? Here XGBoost is an extreme gradient boosted tree. What is mean by boosting? Boosting is an ensemble technique. Here boosting is classified into sequential and bagging. This XGBoost is comes under sequential boosting. It means here different models gets trained and combine all models to get better performance. That XGBoost is giving better performance. And bagging, when it comes to the bagging here, the bagging boost means here parallel models. The XGBoost is introduced a new metric called similarity score for node selection and splitting the data. This XGBoost is constructed on decision tree. So we have to follow these steps to implement this algorithm here. So we need to create a leaf tree. Then first tree is constructed by computing the target label average, that is a base model for constructing the XGBoost algorithm. So first of all we need to calculate the residuals using the desired function. For subsequent trees, the residuals come from prediction made by previous tree. The previous tree is the first tree which is constructed. So we need to calculate the similarity score using this. Similarity score is equal to sum of residuals whole square divided by number of residuals plus lambda. Here there is a very important thing here, lambda. What is mean by lambda here? Lambda is a regularization parameter which is used to control the overfitting of the model. We will use the regularization hyperparameter. Using similarity score, we select the appropriate node. Here, higher the similarity score, more the homogeneity. Using the similarity score, we calculate information gain. The information gain will be calculated similarity of the left node plus similarity of the right node minus the before splitting the tree, that similarity we have to subtract to get the information gain. Then create the tree of desired length using this method. So here very one more important hyperparameter we use in XGBoost is here pruning. What is pruning here? Pruning is adjusting the gamma value, means here adjusting the lambda value because we need to reduce the residuals. For that we will use this pruning. Pruning and regularization would be done by playing with the regularization hyperparameter. So predict the residual values using the decision tree constructed. The new residuals is calculated using this. New residuals is equal to old residual value plus sigma of predicted residuals. So this step has to be repeated for all the subtrees in the constructed decision tree. So I'll go with an example how it is working. So let me see now. Here first of all I'll explain the function here, how we, because in the XGBoost we are training the model in sequential form, one after another, keep on training the base model to get the better results, better performance by combining all the models. That is what F1 function, that is base model. Then we have constructed F2 based on F1, we constructed F3 based on F2, like that set of base learners. The final prediction would be here. So 1 to m we are combining f of t of x of I. Here x of I is input here. This function that minimize the overall loss, meaning here the objective of this is prediction is getting the better performance model. We will use this. Let me see the example here. I am taking the simple data here for the sake of understanding, because same pattern applied to our existing data for predicting the Parkinson's disease based on the input features here. Now I am taking the input feature in this data here for the sake of understanding. X is a independent variable, that is age of the student here. Then IQ value, this is a dependent variable here, IQ. Now here this is age is 10, IQ is 20 here. Then how we are going to calculate the residual values? First let me see how to calculate this. First of all we need to compute. See, in that algorithm I explained you computing the first average of the target label. Then we need to subtract the target label value target label value from the average value. Here 20, the average is 30 here. 20 minus 30, so you'll get minus 10. Then 34 minus 30 will get 4 here. Then 38 minus 30 will get 8 here. Then here let me construct the let me see the age here, IQ. Then here I am taking 10, and then let me construct the correlation here. The point E1 is a residual value, here E2 is a residual. See, the base is, I am taking the base for constructing a new model. Now M0 is a base model. Now when we construct the base model here, this is the base model we have taken here. So the value is here 30 here. The value is here 30 here. Now there is a residual, meaning here error from the base value and the target value. This is a residual one. Then here this is also error is. The objective of any algorithm is we need to reduce the residuals for producing the better results in future. Right, here model M1 is constructed on base model, that is this. Now target features becomes here residuals values for constructing our tree. So let me construct the tree, you will understand in better way. To understand in better way, I am going to construct the tree now here. Yeah, so these are the most used parameter in XGBoost. This I explained you already here. Lambda here, lambda is a regularization dominant factor of algorithm used to get rid of overfitting the model. To come out of the overfitting of the model, so we should use this lambda. Then gamma is a threshold value here. This is used for auto pruning of the tree. It is also controls overfitting. Then another important parameter here, how much model will converge. Then we use eta here, that is how fast it converges for next model construction. For that we use eta here. When residuals are opposite sign, then similarity score becomes very low. Now again information has to be computed for knowing whether the tree is going to splitting or not based on this. So that is a information gain is useful, because here the algorithm which we are using here, so whether the tree is going to be splitting or not, on what basis it is going to split here. So if information gain is greater than the gamma here, splitting is possible, otherwise splitting is not possible here. Here we need aggressive approach if this is satisfied. So we need to adjust lambda value for getting the better model. The lambda will take care of outliers also. So how to calculate the information gain here? Information gain would be calculated using this. I already explained in the algorithm procedure also. This is a gain here, similarity score of left node plus similarity score of right node minus root node will get information gain. Let me see how I calculated it here. The residuals are -10, 4, 8. Then here for this, how will I get this 1.3? Now, so how to calculate the similarity? Sum of gradients here. First of all, we need to sum here. -10 plus 4 plus 8 divided by number of residuals. How many number of residuals are there here? 3 we have here. But plus lambda here. For initially lambda value we need to assume here 0 here, because here the lambda value would be adjusted to reduce the residual value. Initially I have taken 0 here. Let me see how it is going to be. Now 4 plus 8, 12, 12 minus 10, I'll get here -10, 12, here 2 by 3 here. So this is here 2 by 3 here. So we'll get here 0.66 here. So here this is the 0.66. Then same thing like here, we need to calculate the similarity score here. So that is gradient, sum of gradient. So 10 to the power of 2 here, 100. Number of residuals are 1 here. So we'll get 100 only here. For here 12 to 12 whole square 144 by 2 here. So we'll get 72. Here similarity score is calculated like this. Here similarity score, sum of residuals, number of residuals, the regulation parameter. Here lambda is a regulation parameter. So now here, so the new prediction means here the M1 model is here constructed on a base model. The new model will get here previous prediction plus learning rate into output here, right? Let us assume here eta value is equal to, that can be varies in between 0 to 0.3 also can take here. So I am assuming here 0.3 here. New prediction is equal to, the previous prediction is here 30, learning rate I am assuming is 0.3 and 6 here. So how will I get 6 here? The 6 will get here for the last one, because here I am assuming the splitting criteria is here age greater than 10. So now here 4 plus 8, 12, 12 divided by 2, here will get 6 here. That is new prediction is here 31.8 here. This process will repeat till we get low residuals. This is a dependent variable, this is a independent variable, this is dependent variable y, the residual, new residuals are this. Now earlier the residual value is here 4, now it comes down to 2.2, and this here when I for example here 2 by, if I assuming lambda is equal to 1, that is 2 by 3 plus 1, again it is reducing this. So here adjusting the lambda value for regularization purpose, we will adjust the lambda value. That is all about this. Like this, the XGBoost algorithm will work for any data for classification, as well as this we can use it for regression also here. Okay, this is all about XGBoost. Now let me see artificial neural network algorithm. This algorithm is used for regression purpose, that is predicting the severity of Parkinson's disease. First of all, what is ANN? ANN algorithm use the perceptron is a basic building block for constructing our neural network. Each neuron in the input layer represents an attribute, that is column in the input data, that is here x1, x2, x3, these are weights of the input here, w1, w2, w3, so on. Now this is our output, so which would be calculated using this x1 into w1, x2 into w2, x3 into w3, like that. Now here in network, input data is fed to set of neurons and each produces an output. That output is based on activation function. Here the activation function which activates the hidden layer for sending the signal to the another layer. Now here activation function is a linear equation. This is a linear equation. x1, x2, so on, xn are the independent attributes in the input data. These are weights, those are coefficients to corresponding attributes. Here the bias is a constant here. W0 is the bias which is constant. This process involves feeding input to a neuron in the next layer to produce an output using an activation function. This is called feed forward neural network. After producing an output, error is calculated, that is, error means a loss. Now, so there should be a correction in a loss, because we need to adjust the weight to reduce the loss value. A correction is sent back in the network, so this is called back propagation, because we are sending the message to the network again by for adjusting the for reducing the error. That is called back propagation. In artificial neural network, we we are using in this algorithm is artificial neural network, fully connected neural network, that is a fully connected neural network here. A fully connected neural network consists of series of fully connected layers. See here, all the layers are connected fully here. So now this is input here, these are all fully connected with the series of fully connected layers here. A fully connected layer is a function from r to the power of m, this is r to the power of m here, to r to the power of n here. Each output dimension depends on each input dimension here. Now let x belongs to r to the power of m, which represent the input a fully connected layer. This is fully connected layer. Then y, that is a dependent variable. So be the ith output from the fully connected layer here. So that would be computed as follows this. The nodes is fully connected networks are commonly referred to as neuron here. The artificial neural network here will use a sequential model. That sequential model diagram is as follows here. So this sequential model, which consists of layers here. First layer is here using here dense layer. For this dense layer we need to pass some hyperparameter. We'll see this is dense layer, input layer, dense 1, dense here, dropout. We'll see one by one here. This is a sequential model architecture. Let me see one by one. What is dense layer actually? What is sequential model? First we'll see, then we will go for what is dense layer. It is a linear stack of methods that groups a linear stack of layers into the TensorFlow.keras model here. This artificial neural network sequential model arranges the layers of the keras in a sequential order, one after another, one layer after one layer, like that it is arranging here. The flow of data is continued until the data reaches the final layer here. Artificial neural network uses a sequential API model, that is sequential API model. In this sequential model we have layers here. First layer is your dense layer. Dense layer is a layer that is deeply connected with its preceding layer, which means that neurons of the layer are connected to every neuron of its preceding layer. So this dense layer has hyperparameters. Those hyperparameters are first activation function. The activation function is a function that is used for the transformation of the input values of neurons, because it has to transfer the input value from one layer to another layer. These neurons are helping us to activate those neurons. We are using the activation function. Now coming to the another hyperparameter in dense layer is here kernel initializer. This parameter is used for initializing the kernel weights of the matrix here. This is for adjust multiplying these weights with the input here. This is kernel layer, we need to initialize it here. The another layer in sequential model is batch normalization. Batch normalization is a layer that allows every layer of the network to do learning more independently. So we will use this batch normalization for normalizing the output of the previous layer. We will use this batch normalization. Batch normalization learning becomes efficient. Also, it can be used for regularization to avoid overfitting of the model. For that, we will use the batch normalization layer. This will help us to normalize the previous layers to avoid the overfitting. Another important here, dropout. The dropout is a regularization technique to prevent neural networks from overfitting. So why do we use this? So we use this dropout technique to prevent neural network from overfitting. So here overfitting will not give a correct results in the future. For that we need to think about. So for that we will use a dropout. So dropout works by randomly disabling the neurons and their corresponding connections. Here connections or here inputs here. So let's say here this is the input here layer here. We have inputs, that inputs we have given to the hidden layer here. Now here this is a hidden layer here. So to activate this we will use the activation function here. So now randomly disabling the neurons. So which one we disable this, we disable these two here. This is dropout, meaning here dropping the neurons by setting the activation function is equal to 0. So that is dropout. Right? In this diagram we can easily understand how dropout will work. This is all about algorithms which we use in this project. Now let me see the process flow. Prediction of Parkinson's disease using a XGBoost algorithm here. So first of all, what we have to do? So the process is, first we have to collect the data from the source here. The source is here Kaggle data we have to take here. The Kaggle data, so data we are taking here. That is, we have collected the data. That when we have collected the data from the source here, the data could be in any form. But when we collected the data from a Kaggle here, the data is in these two form here, that is archived users data and the TUPI data, which I already explained you. Then we have to go for data visualization, then we have to go for see, the data is in right form, so the algorithm will not accept it here. We have to bring the data into right form to give a better results to train our model. So these data, so we need to do lot of pre-processing here. So for these data also we need to do lot of pre-processing here. Then after completion of the pre-processing here, we need to select the model, which model is going to be used for model building. So that is model selection. Here we use the XGBoost model here, build the model here. Then here the next model integration here. So integration is deploying the model and Flask here. That is save the model and deploy that model and Flask here. That is a web framework. We'll see in the next. Then evaluation of the model. So to evaluate the model, once we build the model, once we consider the model, that model is giving whether it is giving proper predictions or not. So we have to use this evaluation metrics. So we have evaluation metrics for classification. For classification, we use metrics, that is confusion metric, then accuracy score. This gives a how accurately the model is predicting the future outcome. For that, we will use this metrics for evaluating our model. This is a flow of, let me see one by one here. Data, how I applied the data visualization, where I applied the data visualization, for what purpose I did this data visualization. I am exploring the users missing data on the graph. How many attributes are having missing data, that is missing values. To know that, I need to explore the data on the graph. The another one I did in this project is exploring the birth year and then gender, how the data is distributed among the several birth years. So that is gender data and the birth data and tremors data explored for understanding it here. So how many people are having that, how many males are there, how many females are there. So that is the gender here. Tremors here, so who is having tremor, so the number of people are having tremors. To understand that, we explore the data on the data visualization. And exploring other attributes also, I explored other attributes also here in this project here. So this is all about data visualization. This is data visualization is a exploration of data for analyzing our data, what kind of data is available in the data set, how the data looks, whether the data is in a discrete manner, whether the data is in a linear fashion. So on what format the data is there, for that we need to apply data visualization technique here. Then, so another important thing in any machine learning algorithm here, data preprocessing. Data preprocessing, it plays major key role tuning our data. Means your data preprocessing is a technique to tune our data, normalizing the data, transformation of the data, filling some null values, to remove some unnecessary data from the data set here before going to before going to split the data. So we need to do lot of data pre-processing here. Here what we did here, so filling the missing data here, converting string data into numeric data here. Then here I applied the data encoding techniques here, because we have a categorical data in our data set here, that is a binary data, binary categorical values are there. So we need to, if more than one label is there, so we can go for label encoding also. One-hot encoding, what do you mean by one-hot encoding? For example, in our data set we have a impact attribute in the data set. Impact is medium, or impact is mild, impact is severe or none. So here we need to apply one-hot encoding, that is by creating a dummy here. So first base attribute for these categories, for mild, medium, severe and none. So here we have a mild impact, here, severe or medium and none here. Here what happens here, so that will be a dummy variable gets created on the data set here, that is impact underscore mild, impact underscore severe, impact medium. So that, so we need to apply one-hot encoding here. This is an architecture for deploying our machine learning model on the web framework is here. So train model here, this is a trained model here, machine learning model here. So that model we need to load into the last framework. So already trained model we are loading for prediction. So for this, here through front end we need to pass the input feature values. Here this, when we are passing this input feature values to the that is input feature values are x1, x2, so on. Here x1, x2, so on, xn. In our case, so birth year, gender, so levodopa, these attributes we need to pass it to the model. That model will give the prediction based on the trained data, because we need to train that. That results we can see it on the front end here. Okay, so this is architecture of machine learning model with Flask web frame. So another process flow for prediction of Parkinson's severity using artificial neural network. See here, so same thing which I explained earlier, algorithm also, Kaggle data, and so we need to do a lot of here we are applying the evaluation metrics or here mean squared error here. So the data is here, Parkinson's telemonitoring data we need to take here. The algorithm which we have selected here, artificial neural network, we need to build the model. Okay, this is a use case diagram here. So there is an admin here. So here system is here. So gather known data and a known response here. So this is the data which we have collected, raw data here. So prepare the data here, because the raw data which we are collected, so there may be some unnecessary data is there, incomplete data. So that data we need to prepare it here. So once we have prepared, once the data is ready, we need to choose the algorithm and validation. So here we need to examine, that is evaluation. So this is a use case diagram for our model. So now coming to the technical aspects, how I'll show you some code snippets how I'm implementing this project. Let me see here, this is a technical. First of all, so where we have to write our code. Now I'm using Google Collaboratory IDE, that is integrated development environment for writing a code. So the data sets which I am using in this project here, typing data of the participants, archived users, study data, Parkinson's telemonitoring data. So the algorithms which I applied here, XGBoost artificial neural network. The language, so which I am using here, Python and Flask and web framework. So this is what implementation of XGBoost classification model, prediction of Parkinson's disease using XGBoost machine learning algorithm. So first we need to go to the Google Collaboratory here, then we have to load the data here, visualize the data to understand what type of data is available in data set. So we need to apply data pre-processing techniques, selection of feature labels and target labels, separating train and test data here, and then we need to select the model and build the model, save the model to deploy on Flask framework. Then model evaluation. Let me see here, I'll show you how to. Here I'll show you here. So how I am loading this data. So once we downloaded the data here, so that data, so we need to upload in the drive here. So you can upload in your drive. So here drive. So in the drive, so I uploaded my data here. So here collab notebooks here. I'm just following the hierarchy here. So archive data here. This archive data here, as I explained you in the earlier, archive data here. This is archive data here. that is TUPI data and archived users. These data is in text file form. For that, so what I am doing here, so I imported the several libraries for loading it. Here I am using the pandas as a library. This library which will help us to work with the data set here. For seeing the data, supposed to see data, using this library we can see our data here. And this library here, numerical Python library, this library which will help us to create a n-dimensional data with the numerical values. Then visualization purpose, either you can use matplotlib or seaborn. Then here I'm using OS for loading our data text files into single file. So to go to the corresponding directory, so that we can use this OS here. So what I did here, first I loaded the archived users data here. Now there is one more interesting what I did here. So I applied the map here, so I don't want to explain in detail here. See 5:50, because this archived users data in a text file form, see this file is contains the 15 characters, so I need to ignore first 5 because I need to take only user ID, user underscore this or 5 characters. We need to ignore this 5 character. I need to start from there. So meaning here 0 1 2 3 4, so we have to take only 5. That's why we have used this. Okay, this is for loading our data. So I need to combine this both data, because the each user is participant is having its own text file here. In that text file we have birth year, gender, Parkinson's, levodopa, and all the attributes are there here. So there are 217 participants as per this here. So I need to process the data. For processing the data, reading the user file from that folder, I define the function here. So then next here, so these are the column attributes here. So that is birth year, gender, Parkinson's, tremors, diagnosis here, this whether it is the left side or right side. Okay, so these are the columns here. So for this column I need to create a data frame here. I create a data frame here. So this is for processing, adding all the user data into data frame. I just have written this code. So once I've done this, so I'll get the data here. The data is in this form: birth year, data, gender column, then Parkinson's, tremors, here diagnosis here, cited, UPDRS. This is my data here. Then I need to apply data pre-processing techniques here. Because my data is in a categorical form, some data is in a string form, so we need to convert that data into numerical form. So with that, what I did here, I applied the function called toNumeric for birth year, because here birth is having some data is not there here, so some NEN is there. So to convert that into numeric form, I just applied this function, then get it here. Okay, this is data here. You can see the data here. The next here. So now coming to the, we need to clean up the data here, because gender is having two categories here. First category is a male and the other category is a female. So here just I encoded this, that I explained you, label encoding. This is called label encoding, or can call it as a binary encoding also we can call. So right, 0 for male, 1 for female. So I just replacing that with this data here. So now here we have 116 male participants, 101 female participants. Now So here we need to convert remaining attributes data into numeric form. For that I use this same thing like here. The next one is here. So this is called one-hot encoding. This is called, see, as a impact is medium, impact is mild, impact is severe. So this is for one-hot encoding. So this is, I did this. Then you can see that the data is now just display the data. Now we can see number of missing data here, where we have missing data here. That data we can, now here birth year is having some missing data and diagnosis year is also having some missing data here. These many rows are missing in that respective column. That because it is numeric, that we can replace with the mean here. So now we can visualize the data here for understanding here. See, this is here Parkinson's here. So 0 means here not affected, means here without Parkinson's on that particular year. So here this first graph is for Parkinson's disease may not be there in that respective here. Then this is for knowing, so the particular year Parkinson, because we already encoded it, that is 0 and 1. So for that's why we have to use this. Okay, now it is displaying here. See here, so this is a birth year and 1920, 1940 here. This is data distributed among the birth year on Parkinson's here. Then here gender distribution here, most of the people here, this is 1 indicates here female and this indicates male, 0 indicates male, 1 indicates female. This is, and same thing here, tremors, the person is having a tremor here, and then it is showing that here 1 for having tremor, 0 for no tremor, that is false. Then other attributes we can explore it here. See, this is for other side left, side none, side right, UPDR as 1, because we have categories, that is uniform Parkinson's disorder rating scale. This is, so don't know is also there, that is also there, category is there. So this is visualization after data pre-processing. I did this, I displayed the data here. So now what I did here, I replaced because here some data is missing in this diagnosis here, the missing values are that I replaced with the mean here. So now we have to identify the how strongly that dependent variable is depending on independent variable. That is with the help of correlation we can easily identify which attribute is primary attribute for classifying the Parkinson's disorder. So for that we need to explore it on heat map here. So I did this. So it correlation factor from -1 to +1. +1 is indicating strong correlation. This is on first data, that is user data. Then this is for the another one TAPI data here. So we need to combine these two data sets here. So as like same thing we have to go for TAPI data here. This is the TAPI data is having this. This is the TAPI data here. That is day, user key, date here, user key, a date, timestamp, hand, left or spacebar, right or hold time, direction, left, on nine directions are there here. So latency time, that is delay time here, and traveling time here. So I create a data frame here. This is after this. So we need to combine these two data sets here, first users and TAPI data here. So this is for seeing the results of, that is, key stroke on the human body here. This graph says that. So here I need to combine these two data sets here. So I combined it here. So this is combined data here. This is my combined data here. Users copy. Here. Okay, combine users. So here combine the user pd.concatenate first data set, which is archived users, then the TAPI data. We combine both. So then, so it is merging with all columns here. Yeah. After this, yeah, so we need to drop some columns from there here. So then we have to select the train data and test data here. So with using this here, this is a library here. From this library we need to import the function train test plate here. So this is boost classifier here. From this library we need to import that. This is for evaluating the model. So this function will help us to find the accuracy of the model. Then confusion matrix here. Then here I am splitting the data into train and test here, x train, x test, y train and y test, by passing x and y here. So I am taking test size is 20%, train size is 80%. Then random state value, so randomly it is picking the data for training. Here I need to create a instance for XGBoost classifier. Then we need to fit the model. So we need to fit the model. After fitting the model, what I did here, because I have to save this model to deploy on Flask. So what I did here, I saved this model here. So then I predicted here. So the accuracy I'm getting here 97 here. Right? So now I'll show you how to create Flask, because we have to know how to create a Flask application. Let me see here. Here, Flask web framework. Flask is a lightweight web server gateway interface, that is an API for micro level understanding of machine learning algorithm. So we can use this Flask API, web application framework. Flask is a micro web framework. It doesn't require any tool or library here. Directly we can use this. This was written in Python here. Flask can also be used to show the saved models of ML here, that is machine learning. To save the model, we need to use a library called here pickle library here to save the model, and disk or drive here Python pickle model. So is serializes the Python object structure and deserializes the Python object structure. So this is a way to create the project folder of Flask. Now here I created in my drive. So that is Flask with app static folder I created for keeping CSS files to apply those CSS on HTML file. So there is a folder called template folder index.html. So I saved the model, that is model.pkl. This model train model we can load it into the front end, so by using a Flask here. So the user provides input for the required fields on the home page, that is index.html. The user clicks on predict button, then it gives the results on front end. So using this Flask, we can do that. These inputs are sent to the predict route using a method, that is a post method we need to apply, that is @app.route predict. So the method is post method is sending the request to the server to provide the service for predicting the input features. These inputs are now fed to our already trained model which we have loaded here. The results is displayed in the form of the predicted class using render underscore template by rendering this HTML on browser. So with predicted class. This Flask application consists of two routes. First one is home, second one is predict. Home route presents the home page to the user where there is an input form. Once the user submits the form, a post request is sent to the predict route which runs inference on our saved model. So that is two routes we are using. There is a way to create it here. First we have to go to Flask. We have to go to the collab.research.google.com. So after going there, we need to select a new notebook, or else what we can do here. So the saved model and builded model. So directly we can write this code. For writing that, we need to follow some steps to create a Flask here. First, we need to check whether it is installed or not, that is from Flask library, whether this function gets installed in our Google Colab or not, because the Colab runs on Linux here. We need to check those things. Then we need to install if that is not, because we are running on the public IP here, because we are not running on the local machine that runs on the public here. So that's why we need to install this flask-ngrok. This will help us to run our application on public, not on the local machine. So create a basic Flask app here. So this is first we need to test it, then we can go for load our model here. First let me see this first here. From Flask, import Flask ngrok, import run with ngrok here. So app Flask here. Flask is a function underscore name underscore underscore. This indicates that running the current Python module. So here we are running our current Python module. So that you are using. So here it is saying the current Python module. So run with ngrok here. This is once we run app, we'll get the following hint here. So once I'm running this, so first I'm running here. See here, these are the URLs here. First one is here. So this is which runs on a local machine here. This first URL which runs on the local machine. This is runs on our public here, that is on browser. It is running on a public IP here. So then we have to click on this to see the result. But when you are clicking in on this port number, so first it will ask you to register with the ngrok. Here To serve HTML content on ngrok, we must sign up for ngrok account and install authorization token. If you have an account, then install authorization token. First, once you are running that, we'll get this. So you need to sign up. Then if you are not sign up, this will not be runs on the this IP here. So we need to sign up. If you are already having an account, then you have to install authorization token. Then next step here, to install authorization token, we have to stop application. For running application, we need to stop it. Then we have to go to the ngrok.com and download. From here we have to copy the following command to install in the we have to install in terminal, that is on Google Colab. Because here ngrok which runs on a Linux, because that environment is Linux environment, we need to copy this. Install ngrok via apt. So this we have to copy. After copying this, you should go to the Colab. So here we need to install it here. This we have to install. So after installation, we have to copy the account. So that account is yours because a valid account. So we need to copy this. So again, this copied account authorization token, that we have to install again here. So here, so once we install this, then so again we have to run this. Once you are running this, automatically it runs on the server of Flask. So here, so we'll get the output here, welcome to my app. So now let me see how we are going to load our ML model using a Flask. Now same thing. So here what I did here, first, so we need to save the model. After saving the model, so we need to load into our front end. So a pickle.load, we need to load it here. So render underscore template, so it is rendering this on the browser. So you need to route for home as well as predicting. So here the input features that we are having in the model, for those features we need to create a HTML page on index.html. This we need to create it. Final features. So here model.predict, final features. So render template. These steps we need to follow to load our model. Then here the home page with the input form, it is located in the folder here templates, that is index.html. This is styles.css, that should be in a static folder, right? So same thing, like we need to implement in-end regression algorithm. So here same thing we need to do here. I did that also here. Here first I loaded the data here. Here I loaded here. This is for loading. So here what is our target? What are our target attributes here? The target attributes are here motor, but because we find out the severity. That severity is here two attributes, severity attributes here, motor underscore UPDRS, total underscore UPDRS. This sees that motor ability, this is overall ability. So that is target, these two are target variables here. Then so explore our data here. This is a visualization. So for each attribute here, So this is a way to split our train data and test data. Here we need to train our neural network algorithm. So that is by creating a sequential model. So I use this dense layer. So by passing the neuron per layers and input shape and the kernel initializer activation function, I used ReLU here. Then batch normalization, that is for normalizing the previous layer. So this is a dropout for ignoring some of the neurons. So here, so we need to train with the number of epochs to train our model with a neural network. So this is our sequential model. First dense layer, inputs here, the number of parameters in this. So this results will get it here. So this is supposed to see the architecture. So just you can use this. We can see the graph also using this. I display C SVG function we need to use to see the architecture of our neural network. So this is architecture of neural network. So this is a prediction here, predicted value and real values here. So very closer to our real data, because this is not bad, it is good model here, right? This is all about neural network algorithm. Here finally I'm going to conclude it here. So our models will give a prediction of Parkinson disease, that is early stage detection of it can improve patients' health. So then the solution was capable of differentiating among early stage Parkinson disease object and controls with a tolerance. So that, so we have to first identify it, then we can prevent that, so we can improve the patient's health. So predicting the severity of Parkinson's disease, that is neural network, is the most efficient algorithm for predicting the severity of Parkinson's disorder that I did. So integrated with the Flask framework also. So because neural network is the best model for unstructured data, because this data telemonitoring data is in unstructured form. That data so is recorded speech and voice of the patients. So that data is given to the neural network regression algorithm. So all this data is in unstructured form. So that's why I applied this neural network regression. So and here determining the severity. So with this two target labels, that is motor and total motor immediates, right? We can also apply to see the we can also apply other models to see the results, and then we can compare it, then we can go for optimization also. So this is all about IEEE paper implementation and everything. If these are the references, I used it here. Dhanyavad. Any questions, you can contact on this number and you can mail us. Thank you.